All right, welcome to lesson 11. We are working on rigid transformations, so the packet should align pretty well with the video. So if you'll make sure you have the packet out, we can work on some stuff. All right, so the first question here is we want to look at degree of rotational symmetry. Determine the order and degree of rotational symmetry for each polygon. So what does this mean? The order, get this pen better size here. Okay, the order of rotation is how many times can you rotate an object, how many times this one has rotational symmetry, how many times can I rotate it about the center and match up in 360 degrees, how many times can I match up with itself? So if I rotate this, I can rotate this vertex to this vertex and it would still be the same shape because this is a regular polygon. So I'm going to rotate it once, twice, 3 times, 4 times, 5 times. So the order we're going to say is 5 because I can rotate it 5 times and it will still match up with itself. On this shape, if I look at from the center, I can't rotate it. Really just the order is 1. So we don't really talk about that as having an order of rotation because it doesn't have rotational symmetry. It has reflectional symmetry, however. So the second request is to determine and sketch the number of lines of reflectional symmetry. So in this shape, even though I cannot rotate it around, I could fold it. Right? So I could fold it along that line and it would match up. So that would be the reflectional symmetry. Reflectional. Okay, over here, I can't rotate this and match up, but I could fold it. So where could I fold it? I could fold it here. If I tried to go diagonal like this, that's too long, it wouldn't quite work. So I think that's it. Okay, so those are both reflectional symmetry. Now over here, when we have an order of rotational symmetry, where we can rotate it about the center, if we have an order, what we're going to do is we're going to take 360 degrees and we're going to divide it by 5, divide it by the order, and that will give us our degree of rotational symmetry. That will give us our degree. Oops, sorry about that. All right, and in this case, 360 degrees divided by 5 would be 72 degrees. So basically between each of these vertices, there's 72 degrees. Okay, great. Let's look at the others. All right, so there are 6 more. I want you to think about them. Decide where could you fold them? How many times could you rotate them? And what would be the degree of, so find the order and degree. All right, I'd like you to pause the video for a minute, try them, and then hit play again so you can check your work. All right, so in this situation, oops, we have an order of 4. I can rotate that 4 times. Degree is 90 degrees, 360 divided by 4. All right, in this case, we have an order of 5. It rotates 5 times to match up to itself. And again, the degree is 72. Here, similar to a square, is an order of 4 and 90 degrees. Order 2. So this will match up if I rotate it, and the degree would be 180. We have a hexagon, a regular hexagon, order 6, degree 36, and here there is no rotational symmetry. On the next slide, I have the lines for reflectional symmetry. So you can see where here we can reflect there, that matches up. there, there. Check those out. All right, so we're finding where could I fold it. That gives me reflectional symmetry. And how much could I rotate it? How many times could I rotate it? And what degree measure am I rotating through to get the degree? All right. So the next activity, what you're going to do is you're going to tell me steps. So I'll do the first one with you. You'll do the second one on your own. Where to get, so we're getting from this triangle ABC to XYZ, and you need to tell me what do we do, what do we do, and what do we do each time in order to get to the next step. So here I have point P, and this definitely looks like it rotated. It rotated, A was here, now A is over here. So about point P, it rotated 90 degrees. So we're going to say 90 degrees clockwise would be to the right, counterclockwise. So our first step would be that we rotated 90 degrees counterclockwise. And when we rotate, it's very important that we say about what. So we rotated 90 degrees clockwise about point P. That's our first step. All right. Once we're here, the next step is we reflected about this line. So let's give this line a name. Let's just call it WJ. Okay, so we reflected. Step 2 would be reflect over line segment. Let's just say line segment WJ. All right, and then to get from step 2 to step 3, it looks like we stayed the same orientation. We just translated to the right. Well, how can we describe how much we translated? Well, we translated the same length of this line, right? From there to there. We slid the length of that line. So let's call that line RM. Okay, so step 3 would be we translated maybe the length of RM to the right. All right. Wonderful. So here's another interpretation of that. So somebody labeled them FG and ST, translated right, the length of segment ST, reflected across the segment FG. Did I say reflected over? Over and across, either of those are fine. All right, so now you have one. So be careful, we're starting with ABCD. Move to step 1, and then to step 2, and then to step 3. So figure out, what are your steps? What steps did you take to get step 1, step 2, step 3? All right, you try that on your own. Here I decided to label them FG and BS. It doesn't matter, you pick what you want to call them. And there's also point P to reference. All right, maybe we'll pause for a minute. Okay, you guys go ahead and work that out. Please hit pause and you can check your work. Okay, if you hadn't hit pause yet, you need to do it. Try it yourself before you look at the answers. All right, here are the answers. Reflect across the segment. So here our first step, reflect over FG. 90 degree clockwise rotation about point P. So you need all of those pieces. You need the direction, you need how many degrees, and you need to know where you're rotating around, what point you're rotating about. And then we translated left, the length of that segment. Kind of looks like a ray. I see an arrow there, but I think it is a segment. All right. Whew, this is a very blurry page. Okay, I will zoom in a bit. If you could go ahead and write down the steps in your packet, And if you want to open up your packet so you can see the right and left side, because you're going to use the graph and the coordinates, like this coordinate and your steps in order to do this activity. So you're going to go ahead and plot ABCD. And I'm letting you know your packet does not say this in it. It says step 1, but then it's blank. So you need to write in reflect the pre-image across the x-axis. That's your step 1. And if we reflect something across the x-axis, how is that going to change? My coordinate notation, well, I'm going to take, let's pick a color here. I'm going to take the x comma y coordinates that I have above, and how are they going to change? If I reflect across the x-axis, yep, the x is going to stay the same, but the y is going to become the opposite. Great. So our new image, here's our pre-image, our image is going to be the x stayed the same, and the y became opposite. 0 doesn't have an opposite. All right, -1 stayed the same, 3 became its opposite. -4 stayed the same, 7 became its opposite. All right, -5, 4 became opposite. Okay. So that would be our first step. So you're going to graph A, B, C, D, and A prime, B prime, C prime, D prime. You want to label that very carefully. Okay. We're going to translate the new image. Now we're taking this line, this A prime, B prime, C prime, D prime, and we're going to translate the new image 2 units right and 7 units up. So now when we take our notation, we're building on this one. So now we're taking the original to do the first 2 steps. We're taking the original points and we are doing both of these steps. We're first doing this one, and then to this one we are going to move 2 units right, 2 units right, so I'm going to do that to the x plus 2, and 7 units up. Alright, so we're going to add 7 to that -y. -y plus 7. So we're building on each step. Okay, so I got you started. Now we're going to take, here we're going to add 2 to the x, add 7 to the y. Add 2 to the x, add 7 to the y. You got the gist? Add 2 to the x, add 7 to the y. Is that a 5? I think so. Okay, add 2 to the x would be -3. Add 7 to the y would be +3. Okay, so I'm going to stop now. Actually, let me just do one more with you, because this is the one where it gets interesting. Okay, if we rotate the new image 180 degrees around the origin, what does that do to our x and y? The x and y stay in the same place. Hopefully you have your summary sheet, that orange summary sheet. You're going to take the x and y, they're going to stay in the x and y position, but they're going to each become their opposites. So here is where a lot of students maybe have trouble, because this is what we need to do. We need to take our original x, y, we need to do the first 2 things to them, and then to this, we need to make all of this opposite and all of that opposite. So one way of writing that is like this, the opposite of x plus 2, and the opposite of -y plus 7. Woo! Okay, so we made everything up in the x opposite and everything in the y opposite. So really what that simplifies to be is -x minus 2. Notice I distributed that negative sign. This becomes a +y minus 7. All right. Great. So you have 2 more steps to do. I want you to keep plotting each of these images. So if you wanted, you could use your original x, y values and plug into this formula, or you could take these quantities and make them their opposite. The opposite of the x, the opposite of the y. right? Because you already have your x and y. You just are doing the opposite, right? Opposite 7, 0 doesn't have an opposite. Opposite of x, opposite of y. All right, good luck. Keep going on this. Go ahead and hit pause again so you can take a few minutes to work it out. So step 4 and 5 are written here. You're going to reflect the new image across the y-axis and translate the new image 4 units to the right. All right, go ahead and pause and get working on this. All right, here are some numbers. This actually just goes through step 4. I realized in my class we took off step 5. All right, so if you did step 1, 2, 3, and 4, that's where we would have ended up. X plus 2 and y minus 7. Again, we had the opposite of that whole quantity, so be really careful. All right, and then this is what your picture would have looked like. This is actually just steps 1 through 4. So your 5th step would be, it was just starting to get really messy, so I think we decided to chop off step 5 in my class. All right. Okay, so we are going to combine transformations and write the associated functions. So, first thing we need to do is reflect the triangle ABC across the x-axis. So here's my x. So this is 3 units above. If I reflect it over the x, I'm bringing it 3 units below. This is 1, 2, 3, 4, 5 units above. 5 above becomes 5 below, right? All right, so the pre-image of negative 5, 6, negative 5, 6, I went up 6, but now I have to go down 6, right? So that negative 5 comma 6 became negative 5, negative 6. So the x stayed the same, but the y became its opposite. So to get from here to here, the x stayed the same, but the y became its opposite. Right? If we started with x, y, what happened to get from here to here? Oh, yeah, the y became its opposite. All right. So we're going to identify each of those new points. And then the next request was to translate the image 7 units to the right. Well, to get 7 units to the right, if we move right 7, we're adding 7 to the x. So we're going to take x and we're going to add 7 to it. And the y didn't change at all. So we're taking this step and building on the previous step. So here we added 7 to the x. Add 7 to the x, 3, negative 3. Add 7 to the x, 6, negative 5. All right, so then the question down here is, well, what is the rule? To get from the pre-image to the final image after you take both steps, what's the rule? Well, right here. I did the 1 to get 1 step, and then from there, I applied the 2nd step. So x plus 7, comma, negative y. And you know what? I don't like this rule. This rule is missing something. What should it really say? Exactly. Yep, that's what it should say. X, comma, y. First with an arrow. So I started with that and I ended with that. All right, great. All right, take a minute, try this one. Go ahead and hit pause. So now what they're doing is they're saying, okay, what if I did the 2nd transformation first? If I translate first and then I reflect over the x-axis, is that going to change anything? So what happens if we translate first and then reflect second? And it asks, what do you notice about the two triangles that result from the series of transformations? So look at number 1 and number 2 and see, did they end up in the same place? Did it matter? So if we translate 7 to the right, I'm sorry, we're going to add 7 to the x, right? but then if we reflect over the x, what happens? Because we're reflecting over the x, really the x stays the same and the y becomes its opposite. Huh, okay. Our points would end up looking like this. And our rule, what do you notice about the rule? Yeah, it's exactly the same. So in this case, it didn't matter because when I did, so here, what do you notice about, well, they end up with the same rule. It didn't matter which transformation came first, but it didn't matter because one transformation affected the x and one transformation affected the y, and the transformations didn't affect the same thing twice. If we had affected the x and the x again, the order would have mattered. If we affected the y and then the y again. So it's a very rare situation that the order doesn't matter. So we need to be really careful about that. All right. So here you have your original points for DEF. Go ahead and plot those points. Rotate the triangle 90 degrees clockwise. X, Y goes to 90 degrees clockwise. X and Y switch places. And remember that my suggestion for rotating 90 degrees clockwise, if I go this way, it's the one on the right that becomes opposite. If I rotate counterclockwise, it becomes negative yx. Sorry, my pen's not wanting to write. Okay, so clockwise, the negative x is what we end up with. All right, then we need to translate 8 units down. All right. So when we rotate, our x and y are switching places, and I believe this is wrong. All right, I'm going to pause and fix this real quick. No, it's not wrong. I read it wrong. Okay, this says counterclockwise. Okay, so because it's counterclockwise, this is not what's going to happen. We're going to do opposite yx because we're going counterclockwise. Okay, great. And then that matches up a lot better. So x went over here, right? The x switched positions to the y. The y moved to the x and became opposite. All right. And then if we go translate 8 units down, we're just going to affect the y values. The y decreases 8, decreases 8, decreases 8. Okay. Now, the first transformation was this. The second transformation affected the y, and the y had to decrease 8. So we're going to take this, which is now considered our y, and we're going to decrease 8. So the final negative y x minus 8 would be our rule. Right? And I think this is an incomplete rule. Okay, but we know we need to actually put that x comma y in there. Oops. Okay, great. I am going to leave it at that. I want you to try the next one, do the order differently, and see if it matters. All right. You have a couple more. Reflect A, B, C, D across the y-axis, right? Reflect it over the y-axis. Reflect the image over the x-axis. So if you reflect over the x and the y-axis, this is very similar to doing another transformation. Let's see if I can set this up. Oh, there it is. Okay. Take a picture. Alright, let's get these right on top of each other. Okay, so I just kind of copied that ABCD. Alright, so I want to show you that reflecting over the y-axis and reflecting over the x-axis is the same. Gets you to the same place as this. Check it out. If I take this and I rotate about the origin, boom, it matches right up. Okay, so how much did I rotate it if I went one quadrant, two quadrants? I rotated a whole 180 degrees. Now that was counterclockwise. If I go clockwise, 90 degrees, 180 degrees, and it matches right up. Okay, so reflecting over the x-axis and the y-axis is the same, gets you to the same place as rotating 180 degrees about the origin. All right, our rule ends up looking like this. If you think about it, rotate over the y-axis, this happens. Rotate over the x-axis, this happens. So that's what happens when we rotate 180 degrees. I'm sorry, did I say, I think I said rotate. I meant reflect. Reflect over the y-axis, reflect over the x-axis, or rotate 180 degrees. Okay? All right. So you guys have a couple more examples. We're reflecting across the line y equals x. I'm not sure if we had time to get to that in class. It's in the top right corner of your summary of transformations. When we reflect over the line y equals x, what happens is this point 5, 6 becomes the point 6, 5. So our point x, y goes, so our point 5, 6 became 6, 5. Well, what happened? Yeah, x and y just switch places. So now it's y comma x. Okay, so that is our rule for reflecting over the line y equals x. Then it said reflect the image across the y-axis. So then we're taking these new points and reflecting them over the y-axis, and that affects our x. But we have to be careful because now our x is the y, right? But it takes the x coordinate and it makes it its opposite. So if I was going from the original points to the third, so the original points to the image to the final image would go from here to here. All right. So take a minute, try that. I will reveal these, but I want you really need to get this practice. So make sure you're trying this. Hit pause if you need more time. Identify your points. Here are x and y switch places. That's reflecting over the line y equals x. And then the y becomes their opposite. Sorry, the y, in this case the y. But the x value becomes the opposite because we reflect over the y-axis, so the x becomes opposite. The x value, which used to be the y, right, is now the x becomes its opposite. All right, and our final rule is the opposite of x, comma, y. Is that right? Nope, that's the wrong rule. Let's fix that rule. Okay, because we came up with something different. So if we start with our x, comma, y, this x, comma, y, what happened is the x moved to the y position, and the y position moved to the x and became opposite. This would have been the accurate rule. Sorry about that. All right. Okay, let's get rid of this rotation. All right. In each of the figures below, describe the transformations that would map ABC onto A double prime, B double prime, C double prime. So since I see two primes, it seems like I want you to do one thing and then another thing. So you want to think about, how did I get from here to here? This is over 1 up 4. This is over 1 down 4. Okay, so maybe this was just a rotation. Maybe it was a reflection. And there are multiple ways of getting to the same answer. Okay, so I'd like you guys to try that. Work on that for homework. All right, great. That's a good homework assignment. All right. So here it's more practice. It's just telling you to reflect across the y-axis and then translate down 4 units and what's the rule. All right, here you have write a verbal representation of each transformation below. So what happened? There were 2 transformations, but what happened? Tell me what happened. All right. I believe this is all just more of what we have done. So there's nothing new here. There is something where I want to translate or reflect over the line y equals something. Okay. Or x equals something. So we're going to get to that. Alright. This is all stuff that you can do. Okay. So here we want to reflect that triangle over line M, then reflect the new figure over line N. Now, we're not going to be incredibly accurate. We could be if we wanted to. We could make a perpendicular line through a point, and we learned how to do that construction. We are just going to approximate. So if I take that distance there and that distance there, it's about there. Okay, we are just kind of approximating that same distance. If I reflected it over, my C would be about there. Here, that same distance on this side, B would be about there. A here, A about there. So if I reflect that over this line M, it would look like about that. Okay, and then if I reflect that over line N, that distance about there. Here, over here, right, is like a perpendicular line. Here, perpendicular line, that same distance about over here. And it's not perfect, but it's pretty close. Okay, so if I reflect over a line and reflect over a line that's parallel, I believe they told us that M and N were parallel. Oh, yep, lines M and N are parallel. What is another way? Is there another way to transform that triangle to get from here to here? Because this is A prime or double prime. Sorry, it's hard to see, it's so blurry. Is there another way to get from here to here? Of course, yes, we could have just translated that length. All right, so yes, translating would have gotten us there. Okay, what about this? Reflecting over line M and then reflecting that new figure over line N. So now what happens if we reflect over perpendicular lines? If I reflect here and then I reflect there, is that the same as taking this and rotating? Ah, okay. So this is kind of like that 180 degrees, right? If I have the x-axis and the y-axis, and I reflect over the x-axis, it looks different, right? I reflected it over, but then when I reflect it back, it looks the same. It's the same orientation as the original. Reflect, reflect. And I could get to the same spot by rotating 180 degrees. All right, so reflecting over two perpendicular lines is the same as rotating 180 degrees. All right, so that's important. Okay, I know there's more that I want to discuss with you. I think I have it in this one. Let me find it. It's all the way at the end. Okay. I'm not sure we will have gotten to this in class, so we're going to do this on the video just in case we didn't get to it in class. So what happens if I take that triangle JFB and I reflect it about the line x equals 4? So we're going to take triangle JFB and we are going to reflect it over the line x equals 4. 1, 2, 3, 4. This is where x equals 4, right? This is my x-axis. Here is where x equals 4, and I'm going to draw a dashed line to identify x equals 4. Okay, now if I want to reflect it about x equals 4, here I have the point 4, 1, 2, 3, 4, 5, 6, 7, 8. 4, 8. If I reflect it over the line x equals 4, what happens? Like, it doesn't go anywhere because it's on that line, so it doesn't change anything. So J prime is at the same spot. Okay. But if I take this point, 4, 5, 6, 7, 8, 9, 10, 2, 10, 2, and I reflect it over this line, it's 1, 2, 3, 4, 5, 6 ahead. Now it's going to be 6 behind. 1, 2, 3, 4, 5, 6 on the other side. So this is our F prime. And our coordinates end up being 1, 2, 3, 4, 5, 6. 1, 2, I'm sorry, the coordinates are negative 2, 2. Okay. And the last one, 1, 2, 3, 4, 5, 6, 7. This point is 7 to the left of this line. So when I reflect it, it's going to be 7 to the right. 1, 2, 3, 4, 5, 6, 7. And that is my location for point B. So when I draw this new, the new triangle, F, oh, that's not what I wanted, sorry. Let's try again. F, B, B to J, J to F. Okay, so this blue triangle, J prime F prime B prime, has been reflected over that line, y equals 4. Okay, so I want us to look at those coordinates. So let's write out the coordinates of the original for J, F, and B. Let's call it the pre-image and the image. Okay, so the image, J, and the pre-image and the image were both the same. 4, 8. 4, 8. Nothing changed. For F, though, it changed. It started at 10, 2, and it changed to be negative 2, 2. And B started off as negative 3, 1, 2, 3, 4, 5, 6. Negative 3, negative 6, and it became 1, 2, 3, 4, 5. Oh, gotta start at the right place here. 1, 2. Let's get in my way. Okay, 1, 2, 3, 4, 5, 10, 11. Negative 1, 2, 3, 4, 5, 6. 11, negative 6. Woo! Okay, so initially I noticed that the y's didn't change at all. All right, when we reflected over the line, x equals 4, the y values didn't change at all. Only the x's did. Okay, so we reflect over the line x equals, and the x's changed. But how did they change? Here, it didn't change at all. It was on the line, a reflection, and it didn't change at all. How did I get, though, from 10 to -2? How did I get from -3 to 11? All right, I want you to think about that. What normally happens if this is my line, this is my y-axis, right? What happens when I reflect over the y-axis? Yeah, the x becomes its opposite. Okay, so this line, x equals 4, is similar to the y-axis in the sense that it's a vertical line. So my x's normally become the opposite. Okay, so let's look over here. The 4 would have changed, if we were reflecting over the y-axis, the 4 would have changed to the opposite of 4. The 10 would have changed to the opposite of 10. And the -3 would have changed to the opposite like that. But that's not what happened, right? Because we weren't on the y-axis. We had shifted 4 to the right. Right. I want you to think about this. What happened? How did we get those numbers? All right. Think about it. We will talk about it in class the next time I see you. On Monday? Yes, because this is your Friday assignment. All right. Thank you guys for watching and working, and you need to come into next class with this whole packet. It's whatever we didn't finish in class and whatever we didn't do together in the video. All right, Unit 1, Topic 2 should be finished by the time I see you on Monday. All right, have a great weekend.